Now today we shall talk what happens when our program needs more memory and the RAM is small. Then same physical memory is used to store more than one virtual address. We shall see what happens. Suppose disk has following: A equal to 45, B equal to 787, C equal to 29, D equal to 92, E equal to 34, F equal to, what are you saying? Any problem? Now, suppose in computer, disk is there somewhere and somewhere there is CPU is there which has a RAM. Now, we are executing this statement print C. So what is going to happen? That 87 will be brought from disk to RAM. D is disk and R is RAM. Let us call this disk. And on the computer, we are looking for the RAM. So here there is RAM. So what RAM has? RAM has the value of B is inside the RAM. Okay. Now we print B. So the value of D, which is 92, will be brought from disk to RAM. And RAM will have B and D. Suppose we are printing A. The value of A, which is 45, will be brought from disk to RAM. And the RAM will have BDA. Suppose we are printing B again. So what is going to happen? Nothing is to be brought. No disk transfer will take place. And the value of B will be printed. Suppose we are printing A. Nothing will be brought. And the value of A will be printed. Now, let RAM capacity is only 3. Is 3. So not more than 3 variables can be stored. No, this is not a question on paging. It has nothing to do with paging for the time being. Is it correct? Yes. Now, RAM can only store 3 variables, and we have seen that it is storing 3 variables BDA. Now, print E is to be done. So the value of E will be brought to RAM, which is 43, will be brought to from disk to RAM. But you see, our RAM can hold only 3 variables at one time, and it is holding the values of B, D, and A. The question comes that out of B, D, A, one of them has to be removed. Which one is to be removed? B or D or A? Which one is to be removed? B, D, A. Tell me. So a policy is to be decided. One of them is the policy of first in, first out. First in, first out. B was brought first to the memory. Okay. This is also one method which Harshvardhan has told. Is it correct? Those things which have been used many times should not be removed, and those things which are very rarely used should be removed. This is one method. Okay. But another methods are also there. One of them is first in, first out. B was brought first. So B is removed and D, A, and E are in our system. So our victim is B. Victim is B.
Sir, where is 42?
What are you saying?
Where is 42?
Just let me see this. 42E. What is E? E is 43. 43. Is it correct? So RAM will have D, A, and E, and our victim will be B. So we are maintaining the queue of the variables which have been brought to RAM. Is it correct? B equal to 87, D equal to 92, and A is equal to 45 is stored in RAM. When a new variable comes, it is put in the last of the queue. And when the need to its removal comes, we shall be removing the first thing in the queue. Okay. So we are removing B. B has been removed. Victim is B. Victim means the variable removed is called victim. It's victim. Is it correct? That is correct. But the technical name is not sacrificed. In the book, you will find it under the name of victim. And a disk to RAM data transfer is called fault. Disk to RAM data transfer is called fault. Is this all right? So you see, till now, 4 faults have taken place. Is it correct? So one of the method is first in, first out. FIFO means first in, first out. First brought variable will be removed. Is it correct? Next method is LRU. LRU means least recently used. correct? Least recently used. Now, B brought B, it is in RAM. Then we brought D, it is also in RAM. Then we brought A, it is also in RAM. Then B is used again. Yes. B is used again. So we write it as DAB. Why? Because B had been used again. Something which is towards the beginning will have a tendency to get removed. So since B is used again, there is no data transfer. B had been put at the back in the RAM itself, at least logically, even if not actually. So B does not become victim very soon because B has been used now. We shall see, we shall see. Now, A had been used, so A has been put at the last. B, B, D, B, D, A, D, A, B, D, B, A. Fine. Now E comes. We shall be removing this D because D is in the beginning. We shall remove it and we shall write it as BAE. Is it correct? So in case of LRU, victim is D. Victim is D. In case of FIFO, our victim is B. Is it correct? And another method is optimal. Optimal is by looking the future. Will be used after a lot of time in future. Now, in optimal, what will happen? It is B, it is BD, it is BDA. Things remain as such. Now we see D and B will be used in future. And the use of A is not there in the future. A is not going to be used in the future. So we shall remove A and it will be B, E, B, D, E. We see the future. So in case of optimal, our victim is A. Victim is A. Is it correct? Is this all right? Anything more? Is it clear to you? That is a major problem. Optimal is never getting used because no one can know the future. Afterwards, there can be if statements can be there. So no one can know the future. Optimal is only for the understanding and comparison. Optimal, now we shall see to it. Now here, print D will take place. That is correct. B and D will be needed in future. It is not so important that what was used in the past. Important part is what will be used in future. That is correct. It will reduce the number of disk transfers to smallest, but future is not known. It will give you guarantee best, but future is not known. That is why it is called optimal. Optimal basically means that it is guaranteed best. That is why it is called optimal. Is this clear to you? Next time D will be required. So fine. D is already there, nothing is to be done. Next time B is required. So the value of B, which is 87, will be brought from disk to RAM. Is it correct? And what will be removed? D will be removed. D will be removed. So it will be A, E, D will be removed and B will be brought. Is it correct? You see, when A would have been needed, suppose by chance A is also needed, in which order A is needed? Is it correct? You see, which is used far away. Suppose here A is also required. So what we find here, that B and B are needed much near in the future and A is needed far away in the future. So A will be removed. Is it correct, Harsavardhan? In case of LRU, fault will take place here itself because we need D. So D will be removed and it will be AED. And fault has indeed taken place here. We need to bring the value of D, which is 92, from disk to RAM. We have to bring. Is it correct? Let us see. LRU B, then it is BD, then BDA, then whatever is used just now is put at the end. We will remove B and put it at the end. Though not actually, but at least in our minds. It is a stack type thing. A will be removed from the middle and will be put in the end, in our mind. Now E will be put at the last. E was not there, E will be brought and first thing will be removed. What is your doubt? In optimal, it will be BDE. Here, it will also be BDE. Here also it will be BDE. Only in this case, fault will take place and we shall bring from disk to RAM a value of A, which is 45. That is correct. We shall not look beyond, but you cannot say first three because here print D, print B, print D would have been there then. Is it correct? So we cannot say first three, but we shall see the entire future. So in that case, B, D, A will be there, B will be removed, and we cannot say what will be removed at present because much future is not known to us. Is it correct? Yes. What is your doubt? You see, we are doing print B. What is the problem in print B? That is why in LRU, print, when we did print D, then in LRU there was no D. So fault has taken place in LRU and D was brought in by removal of B. I am talking about second print B only. When the second print B has taken place, then in LRU another fault will be there. That is correct. Second B was removed, so B will be brought in, which is 87, which will be brought from disk to RAM, and A will be removed and it will be EDA. Is it correct? Yes. Yes. You see, in second print, BD, BDA, then DAB. What is the harm in second print? Second print is all right. Nilanjan? See the second print. Second print is all right. Any problem now? Any problem? Now, we shall see another method, which is the method of second chance, which is also called the clock algorithm. Now, B is there. B is there. What is the problem? C, D, A is there. Any problem? Here also it is BDA. Here also it is BDA. Now, print E has come. First time victim will be as in FIFO. So our victim is B and we shall get DAE, and it is B, it is A, it is E, and in front of E we shall write it is referenced. You see, in the optimal, or it is a set, in the optimal order is not important, because decision about the A we can only see once we know the future. But after the last print, a future is not given. Is it correct? So we cannot think in terms of the victim in case of last A. Second last. Okay, let us see this. LRU, B, BD, BDA, BDAB, DBA, BAE, and afterwards D is required. So it will be AED. Then B is required, EDB. And in this case, what is going to happen? That again A will be brought in. So what is A? A is 45. It will be brought from disk to RAM. And in this case, it will be EDDBA. Any problem? I am explaining. Second chance, I am explaining. You see, till the first fault, second chance and FIFO are the same. First time when the replacement is to be done, it is like a FIFO. Now, when E has to be brought in, we shall write ER. B has been removed. Is it correct? And the new thing which is E has come, we shall write R in front of it so that it doesn't get removed. Now D. D is R means referenced. Now, what will be the case when print B will take place? It is like a FIFO. We shall try to remove D. We shall try to remove D. Why? Because D is front in the queue. But we see D will be given second chance. Why? Because D is referenced. So our Q becomes this. And the protection bit of the D will be removed and D will be put at the end of the Q. That is correct, fully correct. But you see, nowadays roll number record is banned. Due to R, D cannot be removed. Wait. Due to R, D cannot be removed. So R will be removed from D. R will be removed from D and D will be put at the end. Now, next thing. In front of A now, there is no R. So A will be removed and it will be ER followed by D followed by B. Is it correct? Is it clear to you? You see, B and A are also referenced. You see, B was referenced. Now B was referenced and B was also referenced. Now B was referenced. B was referenced and A was referenced. Now B was referenced. D was referenced and A was also referenced. Now same thing took place here also. Is it correct? You see, initially B was referenced, so we wrote BR. D was referenced, so we wrote DR. A was referenced, so we wrote AR. Now B was referenced, BR was already there, so we let it remain as it is. A was referenced, so AR. Now E has come. You see, there is a method of putting more than one R also, which is called a history bit, but that is much higher. But at present, we are only concentrating on a single R. Is it correct? There is a method, higher methods are also there, which will be putting more than one R also. But for the time being, we are concentrating on single R. Now, E is to be referenced. We will try to write down, make the victim B, but since B is referenced, so we shall remove R in front of B and we shall put B at the last. Now D is referenced, we shall remove R. We shall remove R. Yes. You see, when E comes, then everything is referenced. Why are you telling that only A and B are referenced? Everything is referenced. Initially B came, so B referenced. Then D came, so D referenced. Then A came, so A referenced. B came, B referenced. Of course, it was anywhere referenced. A came, A referenced, anywhere referenced. Now E has come. We will try to remove B, but B is referenced, so we shall put B at the last. Now we shall try to remove D. D is referenced, we shall put D at the last. This is B, DA. Now DBA. Now DBA. Now BDA has come, so B will be victim and DAER will be the case. Any doubt? Any doubt? Print D. D is referenced, DAER. Print B. D was referenced, so D will be put at the back by removing R. Now A is referenced, so A is not referenced, A will be removed, ERDB will be the case. BR. Is it correct? Fully correct. Print E step. You see, BR, DR, AR was there. We shall try to make B as a victim, but it is referenced. So it is removed and put at the end. Now, we shall try to remove D as a victim. D is referenced and put at the end. A as a victim, A will reference and put at the end. Okay? Now, we shall do like this. Is it correct? Okay. Now, any doubt now? Suman, is it clear to you? We shall see to it. We shall see to it. We will try to remove E, but E is referenced. So we shall write D, BR. We shall write D, BRE. Now, B will be removed. So it will be BR, comma E, and A referenced. Is it clear to you? That is correct. Fully correct. E arrived, then we shall try to make victimized from the very beginning. We shall try to make victimized from the very beginning. Is it correct? Yes. Fully correct. Last print B. Krishna. DRAER was there. Print B, we will try to victimize B. We will try to victimize D, but D was referenced, D was put here. Now, VA will be victimized. So ERD will be as it is, and BR will be put at the end. What is your problem, Sai Krishna?
Sir, can you please give the explanation of second chance like you gave for all
This
others?
will give. I will give by a separate example. Okay. We shall see to it. Let us see this. We are assuming RAM capacity 5. We are referencing BCADE. So BCAD, BCDEF, 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 RAM capacity 5, BCDEF. Is it correct? So it will be BCDEF. Up to 5, there is not a problem. B is reference, so it becomes BRCDEF. Then E is reference, so it becomes BRCDERF. C is reference, so it becomes B, C, 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 R, D, E, R, F. Now G is referenced. Is it correct? Then it becomes C, R. We try to remove B, but B was already there. We put at the back. C, R, D, E, R, F. Then D, C. We shall be putting it at the last. D will be coming in the beginning. Now it is ER. D will be removed. ER will be coming in the beginning. F, B, C, G. So it will happen. That is correct. We shall try to remove the leftmost variable. We shall try to remove the leftmost variable. But if the leftmost variable is referenced, then we shall be giving it the second chance. Any more problem? It should be like this only. You are fully correct. It should be like this only. Let us see this. Let us see. Let us start from the A. In the beginning, it will be AR. Now it will be AR, BR. Now it will be AR, BR, CR. Now, up to this place, do you agree? Now, F is referenced. Now, F is referenced. What will happen? We will try to remove A, but A will be given second chance. So it will be BR, CR, DR, AR, BR, CR, PR, PR, CR, DR, PR, and FR. A. Now, we shall try to remove B, but B is referenced, so it will be given another chance. CR, DR, PR, AB. Correct. You are correct. It is like a cyclic queue when the first non-referenced variable is removed and those variables which were in the beginning to this are put at the end. So those variables which are referenced will not always remain referenced. Is it correct? First non-referenced variable is removed, and those variables which were higher in the queue, reference is removed from them and we are put at the back of the queue. That is correct. Okay. DR. So it will be ER, A, B, C, D. So it will be A, B, C, D, E. Now it will be A is removed, B, comma, C, comma, D, comma, E, comma, FR. Is it all right to you or any doubt? No, no, no. Nothing can be more optimal than the optimal Nilanjan. Nothing can be more optimal than the optimal. Is it correct? Any doubt now? Any doubt? Now, suppose C is referenced. It will be ER, comma F, comma P, comma CR, comma GR. Rather, I forgot. In the beginning itself, it should have been GR. Yes. Clock algorithm and second chance are the same. They are the same. Is it correct? Yes. They are the same. Fine. Now, fine. Any problem? This will get converted to ER will be removed and will be put at the end. Now, this cell FR will be removed, so it will be B, comma C, comma GR, comma E, comma F. Now B will be removed, and there is not reference, so it will be B, FR, and you see, this will be B, C, GR. Any doubt? C, GR, EF, KR. Fully correct. Any doubt now? Any question? Any question? Otherwise, let us proceed. Now, let us further see to it. Suppose we write print A. So, the value of A will be put from disk to RAM. And 45 will be brought from disk to RAM. and our RAM will contain A45. Is it correct? Now, we are writing B equal to 67, 74. Nothing will be brought from disk to RAM. And our RAM will contain A, A45, B74. This is what our RAM has. Suppose we write print C. We shall bring the value of C, which is 29, from disk to RAM. What is the problem? And the RAM will have A45, B74, and C29. Now, we are writing it print A again, or we are writing, okay, fine, print A again. So again, there is no data transfer. And for the time being, we are using first in, first out. We shall be doing this. Now, we shall be writing print, or we are writing T equal to 56. No data transfer. A will be removed because there is no space for this. So it will be B74, C29, and B56. Okay. Now we are printing F. The value of F, which is 35, will be brought from disk to RAM. Fine. B will be removed. So it will be C29, P56, and F35. Do you agree? Any doubt? At present, let first in, first out. That is correct. Jan is fully correct. Hence, we need the concept of dirty bit also. Simply, this will not be sufficient. Along with this, the value of B, which is 74, will also be transferred from RAM to disk. Do you understand it? Is it correct? Do you understand it? This will be transferred. Is it correct? So, when we are storing the result onto RAM, we should have some method for the storage about the dirty bit also. What are to be updated? Is this all right to you? Any doubt about it? Now, A and B is called a page. A and B combined is called page U. And page U contains the value 4587. This is called a page V. Page V contains the value 2992. Now, page E, page W contains the value 4395. Page G, C contain the value 9482. Is it all right? Is this all right to you? Yes, 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 yes. Fully correct. Fully correct. Now, we are writing print B.
Hello, sir.
Yes, hello.
In the above line in printf, we should transfer B, sir, isn't it?
That is correct. So I have written value of B, which was 74, has been transferred from RAM to disk. Okay, so B will be transferred. This 87 will change to 74. Is it correct? I should have changed it rather.
Okay.
Is it correct? This 87 should have been replaced by 74. Is it correct? What is the problem? Is your doubt clear?
Yes, sir. Clear.
That's correct. Now we are doing print B. We are making the group of variables. So what will be transferred? 45, 87 full will be transferred from disk to RAM. So page U will contain 45, 78. Now we are writing E equal to 83. We are writing E equal to 83. Is it correct? You are fully correct. Now, we are doing E equal to 83. No data transfer will take place. And we shall write down that U45, 87, we shall write it as it is. And afterwards, we shall be writing it as 43, 35. We shall write here some garbage value GH, E 83. Then some garbage value GH, we shall be writing it here. And we are writing that it is page W. RAM capacity 2 pages. Is it correct? Yes. RAM capacity 2 pages. Is this all right? Yes. Now, is this all right to you? Suppose we write down A equal to 42. Then we shall write it as 4287. Now, suppose we are writing print C. Now, we shall transfer 2992 from disk to RAM. One of them has to be removed. W83 GH will be there as it is, and we shall be writing V 2992, and as we can see very easily that A was updated here, so 4287 will be transferred back, and when the transfer of the W will be required, then little bit more care has to be done, because we cannot write down 83GH directly. In place of E we can write down 83, but in place of F we can not write down the garbage data. So all these arrangements will be made as we were making it previously. Class is over, but I want one question. We can discuss, we will discuss, but I want the students after 18 MA when we can keep their test. Just suggest me something. And UG lab test can be when? Of course, there is a time for it. You said keep in mind and may inform me tomorrow. But can we have tomorrow, when we can have this 18 MA test when you can discussion can be done, anything can be discussed. Now we can discuss from the previous class also.
Sir, what is W83GH? Please repeat that.
W83GH, you see W means page W is 83 and here in place of GH some garbage data will come. Is it correct?
Okay, sir.
Because as it was, who are you, Prof?
Yes, sir.
Yes.
So don't we need some other bit to indicate whether the first
Certainly they are required. As we were requiring them previously, they will be required now also.
Okay, sir. It's just that you haven't written them now for simplicity.
No, only for the simplicity and to avoid confusion. Is it correct?
Okay. Yes,
and
sir.
some policy will be decided about them. I am putting it everything in the chart.
Okay, sir. Thank you, sir.
I am talking to the people of OS3, which is after 18 MA, when we can have their test. Okay. Any discussion can be done. Anything can be discussed. Because you see, to give the value of f, we need data transfer from disk to RAM. Sanket, can you understand it? We want to avoid data transfer. Maybe that here itself f equal to something has been done. I will talk about this. After this, I will talk about this. I will talk about this. But first, let us finish with this. Is it correct? First, let us finish with this. Yes. When the print of C will take place, then 2992 will be transferred from disk to RAM and 4287 will be transferred from RAM to disk. Do you understand it? Now, suppose we are writing H equal to 92. Then B 2992 will remain as it is. Page G मत करो UVWY कर देते हैं इसको. Page Y will be some garbage data, say ST followed by 92 will take place. And now 83GH will be removed. How we shall be able to remove 83GH? 83GH we cannot directly transfer to W. 4335 will be brought from disk to RAM and 8335 is going from RAM to disk. H is equal to 92. Disk to RAM, we are removing W 4335. What is the mistake? Why are you writing 9482? No, wrong. Jannat, you are fully wrong. D is 8335. Yes. Dipankar is correct. No, disk to, no, Dipankar is also wrong. We shall send it later on. Is it correct? We shall discuss first. We shall discuss first.